functions. But now to the examples. Some of these you'll see in the homework. And I think these warrant a little bit more explanation because they're a little bit different. So I did attach a copy of this worksheet to the eCampus page 2 if you want to just kind of follow along. All right, I think the easiest thing to do with these is to actually plot points. So for example, when I have, when you're doing something to the inside, so when with all of these, like for example, we're looking at y equals f of x. So when that number is introduced on the inside of the parentheses, that's going to impact the input of the function, right? So that's going to affect the input. So when I'm going to affect the input, you always have to do the opposite of what you're looking at. So for example, over here, when we were looking at, again, the -2 is on the inside. That's affecting the input. And the -2 actually shifted that 0.00 to 20. We actually added 2 to the x coordinate. So you do the opposite. So in this case, the easiest thing to do is to just start with a couple of points and shift them. So with this one, I'm going to start with the point 0, 0. And then what is that? 2, -4. And then 4, 0. And so if I'm looking at y equals f of 1/2 x, I'm actually going to multiply each input value or x coordinate by 2, the opposite of what's happening in the actual definition. So since this is really x divided by 2, or 1/2 of x, I'm going to multiply each x value by 2. So this would be 0 times 2 is 0, 2 times 2 is 4, and 4 times 2 is 8. And then the y coordinates stay the same. Okay, so let's go ahead and plot those. So 0, 0 will stay. Then we have 4, -4, which would be here, and 8, 0, which would be here. So my new graph looks like this. So you can see when you multiply the inside, again, what this is called is, it's actually a horizontal stretch. Now this one, where we have the 2 is being multiplied to the outside of the function. So this is, again, this is outside, so this is actually impacting the output or y value. So again, let's take 2 points to shift. So let's see, this would be 0, 0, and 4, 4. All right, so that outside 2 doesn't touch the input value, so those stay the same. But when it's an outside value, you'd make a literal change, similar to the vertical shift. You know, over here, this was being added to the outside of the function. It was +2, it shifted it up 2. It does exactly what you think it would. This point was 0, 0, and it became 0, 2. We added 2 units to the y coordinate. So the same thing happens here. We're multiplying all of the output values by 2. So 0 times 2 is 0. 4 times 2 is 8. So again, let me just jot down what that was. That was 2 times g of x. So my new point, again, we'll have 0, 0, and then we'll have 4, 8. So this is what we call a vertical stretch. Oops, I didn't mean to make that curved. It should be straight. That is hard to draw straight. try that again. A little bit better. Should be straight. All right, so difference between our vertical stretch, again, is something like 2 times g of x when we're multiplying on the outside. And the first one, which was f of 1/2 x, this was our horizontal stretch where we were multiplying on the inside. All right, let's jump down to these. So now these entail doing more than one thing. So they might include more than one step. But we're going to take the same approach. So let's start with the first one. And I'm just going to identify some relevant points. So I have -2, 4, 0, 0, and 4, -2. Okay, so let's think about what we're going to do. All right, so first of all, this is happening to the inside. We always want to deal with this first and do the vertical shift last. So let's just think about what this is going to do. So let's think about what y of f of -x will do. So we know this is a y-axis reflection. So again, you do the opposite. So we're going to take the opposite of each x coordinate. Remember, this is happening on the inside, so it affects the input. So this becomes 2, 0, and -4. Again, the y values stay the same. So you can see if we were just doing a y-axis reflection, these things would just flip-flop. 0, 0 stays the same, but instead of -2, 4, oh, that should be -4, shouldn't it? Sorry. The y, we went down. That's a -4. So that's a -4. So it goes from -2, -4 to +2, -4. That would be a y-axis reflection. All right, so as a last step, let's add 3. So again, this is on the outside, so this is a literal move, and it's going to happen to the y coordinate. So our current x coordinates stay the same. And now we're going to add 3 to each of the y coordinates. So -4 plus 3 is -1, 0 plus 3 is 3, and -2 plus 3 is 1. Okay, so this incorporated now, it took y equals f of -x and shifted it up 3 units. All right, so let's plot those last 3 points. So we have 2, -1, 0, 3, and -4, +1. So it should be the y-axis reflection of this graph that is shifted up 3 units. All right, let's tackle part B. So we have 0, 0, 2, 4, and 4, 0. Okay, so the first shift is 2 times g of x. So the 2 is on the outside, so this is going to be a vertical shift, and it's going to affect the outputs, so the y coordinates. So each of the y coordinates will get multiplied by 2. So 0 times 2 is 0, 4 times 2 is 8, and 0 times 2 is 0. So we just get that vertical stretch, and that makes sense. These 2 points would stay the same, but this would stretch vertically up to 8. Then that -1 is going to shift it down 1 unit. So now we're going to take, 2g of x and shift it down 1 unit. So that's, again, going to happen to the output. So my x coordinates stay the same. And I'm going to subtract 1 from my y's. So this becomes -1, 7, and -1. Okay, so we have 0, -1, so that makes sense. 2, 7, and 4, -1. So we see that vertical stretch and that shift down 1 unit. Okay, so these are going to work similarly. Maybe let's jump down to question 4 because that one's a little bit different than the ones that we've looked at. Specifically, this one looks a little different. Again, this time we have the negative on the outside, which would indicate an x-axis reflection, and the -2 on the inside, which would indicate a horizontal shift. So really by looking at this, I can tell it's going to be flipped upside down and it's going to be shifted to the right 2 units. So sometimes you can do that without actually plotting the points. You know, I can see that that's going to be shifted, so I can move all of these points over 2 units and then flip it upside down. And that's perfectly fine to do too. I'm going to go ahead and plot these points. Like I said, sometimes I think it's easier to plot the points depending on the complexity, but some of these it's absolutely acceptable to just be able to visualize it. So just to stay consistent with what I was doing before, I'm going to run through this one this way. So you can do it all in one step once you get the hang of it. Again, the negative on the outside is going to impact the y's, the output. The -2 on the inside, again, inside do the opposite, is going to impact the input. So for the x values, I'm going to add 2 to all of those. And then the y values, I'm just going to change the sign. And then that'll do it. All right, so I'm just going to make my little points. Okay, so add 2 to the x's. So this becomes 2, 4, and 6. And then change the sign of the y's. So we've got 0. This would be -4 and 0. Okay, so we would have 2, 0, 4, -4, and 6, 0. So again, consistent with what I thought by just kind of eyeballing it.